Hello, and welcome to our last pre-recorded tutorial of the whole semester. It's flown by pretty quickly, or at least it feels like that to me. Today, I tried to select some topics that will directly assist you in writing the sections of your final report that we haven't addressed yet, and we'll be providing some information on what's expected for your presentations next week too. It's a short tutorial to balance out last week's pretty long one. Let's get started. So as I just mentioned, this will be the last pre-recorded tutorial of this class. We'll have one more tutorial next week, but we'll be presenting live or meeting live for student presentations. Just like last time, section 105 is at 8:30 a.m. and section 106 will be at 10:30. This will serve as the final tutorial, and there will be no more videos you need to watch or assignments you need to hand in, other than the final paper, of course, after Wednesday of next week. The final research report has an unchanged due date of August 2nd at midnight, and there will be a 10% late penalty per day if it is handed in late. While writing, please consider the comments I gave you for assignment 7. While assignment 7 wasn't formatted like a research paper, you still discussed elements of your project in it. So if I gave feedback about the design or data collection methods of your project, you should consider implementing said feedback when writing your final report. Now, I understand that receiving the simulated data files and needing to analyze it with basic stats and create a table or figure is quite overwhelming. So if you have any questions about your simulated data, creating your table or figure, or anything else about the final report, please drop in today at any time between 8:30 to 12:30. As I mentioned last week, I'm opening up my final slot of office hours today. So even if you didn't book an appointment in advance, you'll be able to ask anything you need to at any time between 8:30 and 12:30, not just the usual 10 to 11. So please make use of this time if you need it in any way. I've had a number of students asking to meet with me outside of office hours, and they seem to be forgetting that I hold drop-in hours each week, and quite a lot of them. I've made it at a time that everyone can make it, because if you signed up for those tutorials, that time is blocked off in your schedule. So please see me today, as I will only be making alternative arrangements to meet outside of this time if it's under a truly extenuating circumstance, because I'm offering so much time today. Okay, so now that we've covered some administrative stuff, let's first get into a practical intro to inferential statistics. This is by no means a formal lesson, as these are pretty complex topics that you'll spend a lot of time discussing the theory behind in PSYC 210. Today, I'll just be giving you a little bit of background and some practical instructions so that you have the ability to infer meaning from your data to report on in your results section and discuss in your discussion section. If you want to dive into this a little bit more, I highly recommend also watching an additional pre-recorded tutorial video made by Lee, another TA of this class. It's not too long, I think it's about half an hour, and I'll be sending around the link to it, which is also on YouTube, when I distribute this video. He dives a little deeper into the theory behind these basic inferential statistics, so in my opinion, it's really worth your while to give it a watch too, just so you understand what you're doing a little bit more. So one of the most basic concepts in inferential statistics is that of populations and of samples. A population of something is the entire universe of a phenomenon of interest, and it's an abstract concept. A whole population of PSYC 201 students is literally every single person who has taken the PSYC 201 class, past and present. The entire population of human beings is all 7-point-something billion people on this earth, and the entire population of, say, people with anxiety is everyone who has or has ever had anxiety in this world. So it's always pretty big. A sample is a subset of the phenomenon of interest drawn from a population. A sample is a much more tangible, non-abstract concept. For example, our tutorial section could be considered a sample of that whole population of PSYC 201 students mentioned previously, and all individuals diagnosed with depression who reside at a certain hospital would be considered a sample of all hospitalized persons with depression in this world. As you can likely imagine, it's nearly impossible to access an entire population of interest. One of the few exceptions to this is when researchers use a country's census data. Usually, it's impossible to even know how large the population is in actual numbers. So, since we can't access the population, we select a sample, we collect data on that sample, and then we try to make inferences about the whole population on the basis of what we are observing in the sample. So one of the main concerns here is representativeness. What if we select our sample badly and we only choose a very specific portion of the whole population? So for example, we want a representative sample of Canadians, but we only select individuals from British Columbia. Or we want to make inferences about all university students, but only sample from the science faculties. In these cases, people in these samples that we've chosen might have certain traits that will skew our data and cause us to make inferences about our population of interest that might not necessarily be correct because we've only got a little portion of what would truly be a representative sample. Something to be concerned about as a researcher conducting stats and something to consider for your own projects. Again, I highly recommend watching Lee's video because he explains just how this concept interfaces with the statistical inference methods I discuss over the next couple slides. So getting right into the practical bits now, one of the most common and basic inferential statistical tests is a comparison between two or more group means. If you are conducting a true experiment where you have manipulated your independent variable and you have two or more groups or levels or conditions of it, etc., then you should be using this method. So how do you do this? You'll calculate the mean of the dependent variable you measured for each group separately and report the values in your results section. Make sure you carefully attend to calculating the mean and median and standard deviation, etc. for each group separately. Since you're manipulating your independent variable and trying to examine differences in your dependent variable, it wouldn't make sense to just report the mean of the dependent variable across all your groups, right? So then after you have all your group means, you'll compare these means and report the differences between them. That's all. Simple enough, right? Well, it's only that simple for the purposes of this class, so I'll briefly touch on another important concept. You've all probably heard of the phrase P is less than 0.05 or have read it in research articles, right? This is a benchmark that tells us, in the case of mean comparison, if the difference between our two or more means is statistically significant. Now, statistical significance is a complex enough topic that you'll spend a good week or two on it in 210. But in the most basic of terms, it's that the probability, so that's why it's called the p-value, of finding that magnitude of difference that you found in your own data in two or more normally distributed populations. So remember last week, that probability is less than 5%. Said differently, there was a 5% or less chance of finding that large of difference in means in two or more normally distributed populations with the same sample size as your own data. So statistical significance is a benchmark that demonstrates to us that it's pretty unlikely to find that large of difference between groups by pure chance. So we can tentatively conclude that there is a real meaningful difference between the groups for some reason, and hopefully that reason is due to your independent variable manipulation. So unfortunately, using p-values correctly requires a little more statistical knowledge, plus conducting an actual statistical test that is based on specific assumptions about the data that must be met. This goes beyond 201, but again, you can see Lee's bonus tutorial if you're interested, because he talks a little bit more about this too. Therefore, all this goes to say that in your own results section, you should merely report which group is the highest and lowest on the measure of your dependent variable and the magnitude of that difference, e.g. was the difference 2 points on the scale, 10 points, etc. But you will not be reporting a p-value for this class. Next, correlations are an index of strength of a linear relationship between two variables. You've definitely read journal articles that have made use of correlations before. If a study says that a variable is associated with another variable, that's a type of correlation. There are many different kinds, but the most commonly seen is the Pearson product moment correlation, or PPMC, which is represented by the coefficient R. So if you're conducting a correlational study where you measured both your independent variable and dependent variable, you will need to run a correlation between your variables. Correlations give us an index of the strength of a relationship between two variables, even if they are measured in different units. So for example, height and age. There are three general types of correlations. Positive correlation, as X increases, Y also increases. Negative correlation, which is when as X increases, Y decreases. And then just having no correlation. So changes in variable X are not accompanied by changes in variable Y at all. Correlations cannot just be any value. They are bounded between -1 and +1. Therefore, any correlation that is a positive value is a positive correlation, and the same goes for negative correlations. The closer a correlation is to either -1 or +1, the stronger the correlation is, where a correlation of 0 is the absolute weakest correlation. So for example, here, an R value of 0.8 is quite a strong positive correlation. An R of 0.27 is a weak positive correlation. An R of -1.0 is a perfect negative correlation because it can't go any higher than that, but you will never see that in reality, so you don't really have to worry about that. An R of -0.5 is a moderate negative correlation, and an R of 0.07 is very, very weak. There's pretty much no correlation there. So how you describe the strength of a correlation will depend on the field you are in. So the hard sciences often find these incredibly large correlations, but a correlation of even 0.4 is considered pretty big in psychology, where there are there's almost always a lot of factors other than the two focal variables at play. Therefore, don't expect to find a super large correlation when you analyze your data, and write about your correlations cautiously. It's best if you find a correlation of a similar value in a published paper that is very similar in topic to yours, and see how they describe their correlation. So do they say it was large or moderate or small, etc. Since almost all of you who will run correlations will create a scatter plot of your data as well, here is how the two are related. So you see how the data points line up if there's a positive correlation on the left-hand side there, negative correlation in the middle, or no correlation on the right-hand side. So those are quite distinct patterns. No matter what your correlation value says, even though you should look at that too, you should also be able to identify the relationship, the type of correlation, if any of these patterns start to emerge in your scatter plot once you've generated it. So if your scatter plot looks like the one on the left there, but your correlation value is saying it's negative, you know that something's wrong and you should probably go check. So this is how you will calculate your correlation. It's super simple. It's quite similar to a lot of the other Excel formulas that I've given. You just want to select a blank cell under your data in your Excel document, and then enter the formula Correl. And enter it exactly like you see on the slide. It's just a little bit different because you're not just taking the correlation of one column, right? You're actually taking the correlation of two columns because they're two different variables and looking at the relationship between them. So you have to figure out in which cell your first variable begins. So in the example, you see A2 to A25 and then B2 to B25. So just make sure that that's all working, and then you hit enter, and then there's your correlation between your two variables, and you can look at the screenshotted example on the slide too. And a last note about correlation and causation. You've probably heard it before, but there's always a couple students who word this incorrectly in their final papers, so please be really careful. Correlation does not equal causation, even if there's a perfect correlation. You may have heard that silly example that everyone likes to talk about. There's a strong correlation between ice cream sales at the beach and shark attacks. Why is that? Definitely not because the ice cream sales are causing the shark attacks or vice versa. It's likely due to warmer weather, a third variable that makes people want ice cream more and want to swim more, therefore increasing opportunity for the sharks. This goes to show that we cannot control for confounds, aka third variables or lurking variables. We can't say that changes in X are causing changes in Y because those changes might be caused by Z. All we can say is that X has some sort of relationship with Y. So I feel like I should talk about this. This may be confusing, but the correlation causation issue is most relevant to those conducting correlational work. So right now, before you listen to this, please try and just think about, hold in your head what type of study you're doing. Are you manipulating your independent variable, or are you measuring it? So think back to tutorial 4 on research design. If you conduct a true experiment with random assignment, you actually can tentatively speak to causation. You do not want to say that your independent variable manipulation for sure caused your dependent variable change, because it could be a faulty experimental design or something. But you can say it may have caused the change, because with the random assignment, you're making your two or more groups as equal as possible on every possible confounding factor, especially if you have large groups. This is only if you are using random assignment though. If you are using a quasi-experimental design where you manipulate your independent variable, but one of your groups is special for some reason, they had to have a certain diagnosis or something, then you absolutely cannot speak to causation again, because that difference could be that third variable that makes one of your groups special. So does this make sense? I know it is, it's a little complex and we've gotten into some convoluted stuff, but at the end of the day, it goes like this. Correlation or correlational studies or quasi-experiments with no random assignment, no speaking to causation. A true experiment with random assignment, you can tentatively speak to it, but nothing's for sure, so don't word it like that. And for one last quick example to illustrate the point, let's remember the schizophrenia researcher in the hospital that I talked about in tutorial 4. She measured the relationship between schizophrenia diagnosis and aggression via correlation, but could not state that the diagnosis caused aggression due to multiple potential third variables like co-occurring disorders, poor treatment by staff, or poor treatment for those diagnosed with schizophrenia, the higher likelihood of command hallucinations in individuals with schizophrenia, et cetera, et cetera. There's probably many, many of them. So we're at the end of this section, and I just wanted to speak briefly about the mechanics of actually writing your results section. First, be sure to delete your anticipated results. We don't want to have both of those sections. You have your actual results now. When you're writing your results, first report on all the important values you've calculated, e.g. your means, medians, modes, standard deviations, verbally in text. Additionally, make sure to reference your table or figure in text at some point in your results section. You cannot have a table or figure just floating around at the end of your paper, but not verbally discuss what it means in your paper. Then compare your means if you ran a true experiment, or calculate your correlation if you measured your independent variable. If your dependent variable is nominal, compare proportions or frequencies instead of means. So I know I didn't really talk about this much in this tutorial. It's not too different. Just see me if you have questions about this. Finally, write about all your results in this section matter-of-factly. Don't interpret them. So there are always one or two students who make this mistake, so listen quite closely. Do write something like this. The difference in means between group 1 and group 2 was some value, and just stop there. That's good. Don't write something like this. The difference in means between groups was some value, therefore this could mean that. So you see in the second, you're trying to also discuss what the difference actually means. We don't do that in the results section at all. We just report everything, and we only do that in the discussion section. All in all, the results section is usually quite short in these papers, half a page quite usually to 1 page at the very most. Next, let's move on to writing the discussion portion of your paper. The goal in your discussion is to put your findings in context. This is where you interpret your results, not in the results section. First, I recommend that you briefly summarize your results. Don't reference your actual values here, that's not necessary. Just say what you found. So for example, group 1 was higher than group 2 on the measure of X construct. Then, if you found what you expected, so your hypothesis was true, then what does that mean? What are the implications for theory, the literature, real-world application, and future studies? Conversely, if you did not find what you expected, so your hypothesis was proven incorrect, what does that mean for all of the above areas? What are the implications of that finding for theory, literature, real-world, future studies, etc.? Remember the funnel, which was the helpful tool when writing introductions. I find the reverse funnel equally helpful when writing discussions. Just as I said on the last slide, it's good to first restate your research question or hypothesis and your broad findings to remind your reader what research question your study specifically sought to answer and what you found. Then consider the direct implications of your findings for the area of study or population that they are most relevant to. If you found that X treatment for anxiety was better than Y, what might that mean for future treatment of anxiety? How may we incorporate the new elements of this better treatment into existing treatments cost effectively in a way that will benefit individuals with anxiety the most? And lastly, discuss the broad implications for society and policy. When writing this, think about why your study was important, and now that you have your results, situate them in that context. What are some suggested changes in society, in policy, based on your findings? After you considered your project's implications on specific and broader levels, you should consider its limitations. Most of your discussion, for example, the previous parts discussing the implications, can fall under a general discussion heading, but you should include a separate subsection near the end titled Limitations. For this subsection, think about the potential limitations of your study. A few common ones are sample size, sample composition, limitations of your measurement methods, and limitations of your research design. Basically, was there anything that could have gotten in the way of you answering your question satisfactorily? Also, don't just say that you were limited by sample size and leave it at that. That's just a very slapdash limitation that won't get you high marks if that's your only one. Think more critically and discuss other aspects like sample composition or design limitations. Maybe you found a relationship between two variables, but couldn't speak to causation, which limited your conclusions. And lastly, a solid discussion section ends with a future research subsection. Here you can have some fun and address some of your previously discussed limitations. What could future researchers do next, or do better, or both? Should the same study be done with a different sample? Should another variable be examined? Should a different research design be used that permits more structure, or conversely more flexibility? If you were one of the students who had very grand ideas of a very complex study and I made you cut out a variable or two, this is the place to discuss that and recommend that that the more complex design be done for future research. And as with the limitations section, don't just say this should be done with any random other population, because that's a cop-out. Make sure that the recommendation actually makes sense. So you can write that your study should be replicated with a different type of sample, that's fine, but you would need to expand on more on why it should be done with that specific other sample and not other samples. There has to be a reason, a logical reason for that recommendation. Both the limitations and the future research subsections should be fairly short, about half a page or so don't sweat them too much. Just put a little thought in and be creative. Now I'll quickly discuss your presentations next week to end the tutorial. The format will be very similar to that followed in the proposal presentation tutorial that we had about a month ago. Students should all prepare a 5-minute maximum presentation of your entire research project. It should include a couple things. First, a very brief overview of everything you presented before, your introduction, research question and hypothesis, and methods. I would recommend strongly to keep it to 1 slide per each of these sections, so 3 slides in total, if not less, just to keep it very short. No need to reference every single one of your 5 lit review studies, just pick the most important ones, and you only need to state your research question and hypothesis. You don't need to explain the rationale behind it again here. That should be fairly clear from your lit review anyways, if you've done this well. The next parts of the presentation are really what matter. Include results from the data you analyzed, so your mean comparisons or your correlation, including your table or figure. This is integral, and I'll explain on the next slide why. The discussion of the results should only take 1 to 2 slides. And then prepare a short discussion section of the implications of your results using the instructions I just provided for writing discussion sections. This should be 2 to 3 slides at the very most. Just be brief and save all the detail for your paper that I'll read. I should stress here that timing will be very tight. If you remember the last tutorials that we presented in, we were rushing at the end, and I don't want that to happen again because I know that gets stressful for the people who go at the end. Last time, only 12 out of 15 students presented in each tutorial, and I do anticipate more students wanting to present as it's actually worth more marks this time. Therefore, you really must keep your presentations to 5 minutes. I will be watching the time, and I will need to cut you off if you go over to make sure everyone has their turn. So if you think about this and you are only, or you spend a lot of time on your introduction, research question, methods that we've already heard about before, and I cut you off before you actually get into the results and discussion, I won't be able to mark you for that. So you really don't want to do that. I'll be providing 1 point or so of feedback too for each person, but nothing like I did last time, just because we really won't have the time. Finally, you absolutely must be ready to screen share via Zoom when it's your turn. There were a lot of technical issues last time, and we just won't have time for that this time. So if you're unprepared and unable to share when it's your turn, we will just have to skip you, and you'll need to figure it out and go later if there's time. One final reminder, presentations will be taking place next week on July 28th at 8:30 a.m. sharp for 105 and 10:30 for 106. Use the same Zoom link as you do for office hours. There will be an email that goes out the night before with this Zoom information again too. So for grading, the presentation differs from last time in grading. The entire presentation will actually be worth 4% of your final grade, a little more. So please attend and present. It's really in your best interests. This 4% will make up the final portion of your weekly assignment grade. So it will serve as your grade for both assignments 9 and 10. Of the 4%, 2% will be earned from just attending the tutorial and presenting something to do with your project, just like last time. The other 2% will be earned specifically from presenting a table or figure of your results and describing its meaning briefly in a sentence or two. Be sure to not forget this part of the presentation, or you will only be able to earn 2 marks out of 4. It's in your best interests to prepare these tables or figures early too, as I can give feedback briefly after you present, and you will need to include one of these in your final report to get full marks. So yeah, it's just in your best interests to have this prepared a week or so in advance of the report being due. And that is all for our pre-recorded tutorials this semester. Thank you so much for watching. My drop-in hours are very long today, like I talked about at the start of the tutorial, so please attend if you have questions about anything. I'll be on Zoom until 12:30. Since students may have booked meetings during this time, please be patient if you are not admitted immediately, as I will be with another student if that happens, and will admit you to the Zoom room ASAP after I'm done with them. It's been great to be your TA over the past couple months. Again, if you have any questions going forward about research involvement, graduate training in clinical psychology, forensic psychology, or anything like that, you have my email address. Don't hesitate to reach out now or in the future. See you all next week. Bye.